So, differentiation and its applications. This is a key part of maths in A-level, so AS and then into A2 you'll be using it a lot. It's one of the most important things you'll ever learn. Someone once asked me what differentiation was ever actually used for, and as a physicist I can tell you it's basically used for everything. If you want to find something's velocity, you differentiate. If you want to find the rate of change of anything, then you need differentiation. So it's very important. So we won't have a look at like the detailed differentiation derivation, but we'll just see how it applies for an x squared graph and why dy by dx of x squared just gives 2x. So if we take our x squared graph like this, and we find 2 points on it, x1, y1 and x2, y2, and we know that these x points are displaced by this little distance here, which is h, so they're h distance apart, which means if this one's just x, then this one's x plus h, and this one's going to be what the y value was, is going to be x squared because it's a x squared graph, which means our y2 is going to be x plus h all squared, because whatever your x value is at a given point, the y value is going to be that x value squared, like so. And then we know differentiation's dy by dx, so we've got the difference in y values, x plus h all squared minus x squared, and our difference in x values, which is x plus h minus x, which is just h, as shown up here. Then we multiply out x squared plus 2xh plus h squared minus x squared, and we simplify it down. 2xh plus h squared over h, because the x squareds cancel, h over 2x plus h, h times 2x plus h all over h, 2x plus h, and when you differentiate you take it as an infinitesimal difference, so when h tends to 0, as h tends to 0 this just tends to 2x. So that's just a quick little proof that x squared differentiated is 2x, and if you want to check it for anything else then just do the same kind of thing, put your x values in and put your plus a infinitesimal difference h, keep it in there, find out what you get, find the difference between the two values and keep solving as much as you can, have h tend to 0, and if you did a cubic you should get 3x squared as your answer. The general rule for differentiation, ax to the power of n, you differentiate it, so you times by the power and then minus 1 from the power. So some of the applications, you can use differentiation to find the tangent to a curve or the normal of a curve. So by tangent it's a point that runs parallel to the curve at that point. So if this would be gradient m, and once you've got the gradient and you know the value of the point, because it'll have to give you the x value to find the gradient in the first place, then using the coordinates and the gradient you can find the tangent, the equation of the line of the tangent. For a normal, it runs perpendicular to the curve, so minus 1 over m, so if you want the normal you take the negative reciprocal, so you take the negative reciprocal of this gradient here, and that gets you the normal running in this direction. Just a quick equation to relate to gradients that are normal to each other, m1 times m2 equals minus 1. So stationary points, these are very important. This is a maximum or a minimum on a graph. So as you can see here, the gradient at each of these points would be 0. And this one here is a maximum, this one here is a minimum, and this one here is an inflection. And that's an example of all three of them there. So if you differentiate it again, so after doing dy by dx, you then do dy by dx again of what you've got. d2y by dx squared is less than 0, then you've got a maximum. If it's greater than 0, you've got a minimum. And if it's equal to 0, then it can be any of the three. You can also check by subbing in a point either side of x and seeing if it's increasing and then decreasing, it's a maximum, if it's decreasing and then increasing, it's a minimum, and if it's increasing and increasing again, it's an inflection,